you for being here on time. I'm saying this just because I'm the one starting tomorrow, so sleep in the park. After the park, you'll figure it out. So now we're going to talk about Squeak and Spur and
Great.
And Etoys.
Yeah.
Right. Okay. Thank you.
So this is obviously the wrong talk. That's the one I gave yesterday. This one. Oh wait.
Yeah, a little.
This better?
Not that much.
Not that much. Okay. How about that?
I think.
All right. But I'm just going to continue where I left off yesterday. And I mentioned it briefly, but the way I did this presentation yesterday here was, of course, in Squeak, in Etoys. So, yeah, you've seen this one. What I'm doing here is, this is Etoys. This here is an Etoys book, where I just turned off the controls. So this is the book, and if I say, okay, make my page controls visible, then you see, oh yeah, it's actually a Squeak book, and it's really just that the color of the book is invisible because it's the same as my background color. So if I change the color of my book, you start to see, okay, oh, that's the book, and this here is the background, and that's one way to do presentations in Etoys. How do I do the reveal? Well, I have a little on-click action on this cover thing here. So when I click, it just moves down 120 pixel each time. See? So this here is actually my little thing that reveals the objects. And so Etoys is a versatile tool for a lot of things, including giving presentations, doing simulations, working with kids. But it's been left behind a little bit. So we were stuck with the interpreter VM, and in the meantime, that guy over there did a lot of work on making a really fast VM for Squeak. And so we wanted to get Etoys over to the new world, which would be Cog and Spur and potentially Sista and whatever else is in the works to make a really fast system. So this here is Etoys. So we can just try to benchmark it, tiny benchmarks. This is the interpreter VM. And so we do hope for a really nice speed up. So I'm going to put some commas here. So that's one. Well, that's actually quite a lot. 25 million cents per second and over 1 billion bytecodes per second. So the interpreter is fast on machines now, but Cog is a lot faster, right? So, nope. So what we want to do is have the same thing in Squeak. So this is the current release image, and if I do the same benchmark here, good morning. So that's 3 times the bytecodes, but what's really important is this number. Yeah, that's way faster than the interpreter. And this helps across machines, and especially for Etoys, which is used in schools that don't often have a $3,000 laptop for each student. Having a faster VM helps a lot. Also, we have Etoys on the old PC laptops that have ARM processors now. We have Scratch on the Raspberry Pi, for example. So having a faster VM for slower machines helps, especially the slower machines. It helps the fast machines too, but especially on slower machines. So the thing with Etoys, well, it diverged. So the last common release where we cross-merged stuff was in 2005, I think, the Squeak 3.8 release. And then Squeak.org took off and got Monticello, and it got Cog, and it got Spur later, whereas the Squeak Land branch of Etoys had all the old PC additions to it. So the old PC, that's the little green laptop they have over in Uruguay and all over the world, used in education settings. And I ported Etoys to that machine. Basically UI stuff that I did there, but I did nothing to improve the performance or so Spur wasn't around, Cog wasn't around back then. But now we want to move over all the work that we did in old PC to a current system. So this is the current system, and the major thing is that Elliot likes to make things really fast, and so he cannot care about backwards compatibility too much. If it's okay, if it's easy to do, yes, but if he needs to change things to make things go faster, he does so. So he changed the object format and closures, yes. So closures isn't that big a problem for us. That's just the mechanics of changing the system, like moving it forward. The bigger problem for us was image segments. So image segments is an interesting technology we have in Squeak, where in the age of the interpreter, serializing objects was very slow. Yeah? And a project is basically everything you see on screen. So it's one desktop. That's actually a really old technology. Should I do a little aside, maybe? So this is a really old Smalltalk here. This is Smalltalk 78, which is basically the same as Smalltalk 76. It's an image that Alan worked in. This is running in the web browser. Basically the same technology as Squeak.js. I basically took the Squeak.js interpreter and retrofitted it to run the Smalltalk 78 byte code and have the graphics there, so you only have white and black pixels because colored pixels were too expensive back then. So you had to deal with black and white. And so he used this, and even back then we had projects. So in the original, well, I don't know when it started, maybe in this Smalltalk 72, but at least the 74 and 78 already had projects, which is just a little thumbnail here, but then you can enter this and you get a full new screen, and that's your desktop. And that's a really cool thing inside of Smalltalk. I think yesterday we touched on that, that in your image you can have multiple desktops and multiple working environments and store everything. So Ralph touched on that in this talk, and also about the concept of the image where all your stuff is in. It gets tricky when you want to transfer these things to another image. Like, how do you do that? Well, you have to, it's all objects, you can just file it out. Go to parent project here. Okay, so we return here. This is actually a nice presentation Alan did. You can look it up on YouTube. It's called Ted Nelson something, tribute to Ted Nelson. So he gave the presentation using Smalltalk 78. It's actually pretty cool. Okay, that's the aside, the historical note. So to have the serialization of projects be very fast, The folks around Denning-Knowles invented, I think they invented that, but I'm not quite sure, the concept of an image segment, where you just take a snapshot of the object memory and file it out. So basically what happens is that they use the garbage collector to find all the objects that are held by basically by the global project variable. So everything that's in there gets copied into an image segment, which is just a big byte array, and that gets snapshotted to disk. So that's pretty fast, but what's even faster is loading it, because if you load the file into the object memory, all the objects in it are already at the right place. So all you have to do is change some pointers in there. Basically everything that refers to stuff that's outside the image. Just replace that, but you don't even have to copy the objects. They just stay in place, and basically they become that big byte array into a series of little Smalltalk objects in place. That's pretty cool. It's also pretty dependent on the actual object format. So what we needed to do to be able to load old projects into a current Spur image is this here. So I made another class, it's called Old Image Segment, which basically has the code that is needed to bring an old image segment in, and I made an old image segment loader, which is here. Actually, as a little side note, there was we assigned that to a student project in the University of Potsdam, Germany. They work with Squeak a lot, and so that was I think a bachelor's project. So students that are 2 years in maybe had half a year of Smalltalk experience and tried to do a really good object-oriented way to write that thing, and they ended up with, I think, like 20 classes and about 100 methods. So it was really nicely refactored, except it didn't work. They wrote a very nice user documentation, like nice HTML and Bootstrap and like responsive design on the website and all that. But they managed to load some objects, but if there was a class object in the segment, then that didn't work, and so all kinds of things. So I had to go in, and I wanted to reuse some of their code, but couldn't really. It was okay. They learned a lot. So this is my little loader. So it's really just, I know people, what's with my sources file? Okay, sorry, this is decompiled code. That's not my current image, so. Sorry for the magic numbers here, but yeah. I know it's 6502. That's our image segment magic number. So basically, it just loads it in, and while we don't have the all objects, we just read an object. Reading an object is basically just decoding the old format. And look here, I used named constants. So so depending on what's going on there, it just reads it. And then it allocates the object that it wants there. So to allocate an object, we're here. Depending on the object format, it's a fixed size object or all these interesting things. Fixed and variable object might be interesting because that's compiled methods, and to make a compiled method, we actually need to fetch the class. So we're in here. And so context is another thing where you need to know the So for the methods, we need to know how many literals are in there and how many bytecodes, because that's how they're stored. So there's various things that we need to do, even just to allocate the object. There's no way to. So compiled method basic new basically says, do not do that. I hate you, because it's this weird object where you have the object references and bits in the same object. So you have to know the literals. So you basically have to analyze the thing that you're trying to allocate. For all other objects, they're allocated first, and then later, when all the other objects are imported, then they get filled. Yeah, so if you have a regular object, then here, so fill pointers. So that's very, very simple, right? It's just that the instance variables are filled, mapping the oops in there, and this really would be better with variable names. I'm sorry. Okay, 5 minutes. So in the end, what I'm saying is we did it. So what I can do now is, let me go out of the full screen mode here, is that I can actually take an older project, where documents, Etoys, let's say this cars project here, where is it? Cars. And drop it in here. What? This worked before.
Reset.
I'm not sure what happened. Is this a wrong image? I don't know. Okay. What we use this for is the following. No, here. Where's this Etoys? So if you want to try this. No. Okay. Let's just show it this way. Okay. So here's Etoys. And here's the little cars project. We put it in here. And this also now works in the Etoys beta system. As I said, it's beta. It's probably half a year at least from the release. So Etoys 6 will be based on Spur and Etoy and the current trunk image, which is also good for the Etoys developers because they will be in the Squeak community back there. There's no split anymore, so we combined them, and we are still looking for help. And I'm also hoping that Ricardo and his friends, colleagues, will bring physical Etoys over to the new Spur. So they're looking forward to the performance enhancements too. Okay, so I'm sorry for the demos that didn't work, but that's basically it.
The image segment. When you are, let's say, assembling the objects from the segment into the memory, you are running small code, so the garbage collector should be stopped somehow to keep the relative pointers options. So the question is the garbage collector a potential threat to the loading?
No, it's not. The way well, the way it worked before, it would have been because it relied basically on the next object pointer to find all the objects in the segment. But the way I implemented it is that I just, when I create an object, I just put it in an array. And so in the end, we have an array of all the objects, and that's how we can iterate them. Since we're on the Smalltalk side, we are not really using the OOP for anything except for looking up, okay, we're putting all objects into a dictionary that's mapping from the OOP to the object, and that's how we can store the right references into the variables. So the garbage collector doesn't interfere. It doesn't matter where the objects actually are in memory.
Is the smalltalk-78 image available?
So smalltalk-78 itself is available, yes. This image of Alan's is not. And I mean, you can ask him, but I cannot give it away because it's just, yeah.
Where is it? Is it in your page?
So smalltalk-78 itself is, let's see, I think if you just Google for it, smalltalk-78, maybe my name, I don't know. Oh, there's another talk I gave, the Squeak chest. This is something we wrote, and it's not in this top. So it's on Lively, the Lively kernel. That's one, yeah. Okay, so Smalltalk-78 and Lively, that gets you to the Smalltalk-78 page. That's the Lively version of it, and then there's also ThingLab, which is a standalone version. So that's cdg labs/ThingLab, which is Alan Borning's old Cassowary thing that's just running in the web browser now here. So there's a little help button here for the command keys that you need to know about, but basically here you can move a point. So this is from 1975, more or less. We want to move a point, and so that's basically the menu. And I hear this is a lot faster than it was on the Alto, but running in JavaScript in the browser. So yeah, it's an interesting thing to look at, and also you can just open a system browser and then look at the stuff, and yeah, no block contexts yet. It was a little thing called remote code, and then you have assignment arrows in the selector, and it's interesting to look at. No meta classes. So yeah. Okay.
Thank you.
All right.